Hello, everybody, and welcome to the webinar, Exploring the Latest in Thread, presented by the Thread Group. My name is Anne Olivo, and I'm the co-chair of the Marketing Committee within the Thread Group. And before we get started, I want to share some tips with you for the best experience during the webinar. So you'll notice that there's a Q&A button at the bottom of your Zoom interface. We are asking that folks, if you have questions along the way, please use this Q&A feature so that we can keep track of all of the questions that come in. We will do our best to answer all of those questions, and a recording of this webinar will be made available on the Thread Group website, and it will be emailed out to all registered attendees of this webinar. So before we begin, I want to go through our agenda today. I'll start by introducing all of our speakers, and then we'll go into an overview of what Thread is, the benefits of using Thread, how Thread works, and then what to expect from Thread in 2025. At that point, we will wrap up and open it up for Q&A. So be sure to add your questions to the Q&A. So now I will introduce our speakers. Today, you'll be hearing from Sujata Naidig, who is the VP of Marketing for Thread Group, and she's also the Marketing Director of Connected Processing at NXP. Next, we'll hear from Stuart Cheshire, who is a board director with the Thread Group and the inventor of Bonjour, also known as Zero Configuration Networking. He also served on the Internet Architecture Board, and he's a longtime leader in the Internet Engineering Task Force, or IETF. I'll go ahead and introduce myself again. I'm Anne Olivo. I'm the co-chair of the Marketing Committee within the Thread Group, and I'm also in charge of international marketing at Silicon Labs. And finally, we'll hear from Daniel Mineta, who leads business development for North America for Thread Group, and he also represents marketing and product strategy at Samsung SmartThings. So with that, I'm going to pass it over to Sujata to give us an introduction to Thread.
Thank you, Anne. Very excited to be here with all of you today to dive into first about what is Thread. Many of you may be aware, but Thread is a technology that has been in the market for quite a while. We actually recently celebrated 10 years since Thread Group was launched, and now we have been seeing much adoption of Thread in the market. So let me start with some of the foundations around Thread and the principles of what Thread was built on. So first of all, the main highlight about Thread is it's a technology that's built using the power of the internet. So really leveraging the internet into bringing that into embedded devices and into constrained devices. It also uses broadly available radio silicon from IEEE 802.15.4. These radios are the same radios that have run Zigbee for 20 years or more, and Thread can seamlessly also run on the same silicon. As I said, Thread is really designed to be optimized for embedded devices, so where there may not be a lot of resources available and providing the best implementation. Thread was also designed to provide for low power and extended battery life, so not just days, but months or years of battery life. The other key ingredient around Thread is that it is designed to provide reliability and extended range by being a mesh network, so that easily scales to cover the entire area needed to. With that in mind, Thread was also designed to be secure and simple to use to implement. The diagram on the right, you can see, shows a picture of exactly what parts of the connectivity stack Thread is covering, while leveraging other technologies that are already deployed. So like I said, the foundation of Thread is built on the 802.15.4 MAC and PHY. You can see the orange circled boxes here is what the Thread specification covers. So about the 6LoWPAN, how to do the IP routing, the TCP UDP implementation, and along with all of that, security and commissioning. The application that sits on top of Thread can be provided by a number of different ways. Thread is focused as the network transport and can support a combination or multitude of application layers. So let me go into a bit of what that means about having the application layer be agnostic. So in this diagram, you can again see the orange boxes, which is what Thread covers. On top, you see the blue colored boxes. These are examples of different application protocols that run with Thread. I'll walk through them one by one and also in the categories. So some of these are more applicable in commercial building applications, while the others are tailored towards smart home applications. So DALI Plus. DALI Plus extends the traditional DALI, which is digital addressable lighting interface, by incorporating wireless and IP-based networking. Thread supports DALI Plus and has supported it since 2022 and provides a robust, low power and IP-based wireless mesh network. This allows DALI devices that are using DALI Plus to communicate using existing DALI commands over a Thread network and enabling flexible and scalable lighting control solutions. KNX. KNX IoT is a specification and a certification program for building automation launched by KNX Association. KNX IoT is the first iteration of KNX as a standard designed specifically for IoT applications and that works over IPv6. Support for the protocol over Thread was announced in September of 2022. This integration allows KNX IoT devices to communicate seamlessly over Thread, ensuring interoperability with existing KNX infrastructure. So now moving into the smart home applications that run on top of run on top of Thread. Apologies for that. Matter is a new protocol that many of you may be aware of. It was announced in December of 2019 and fully launched in the fall of 2022 and has had twice-a-year releases since then. Matter is an open smart home protocol that uses familiar technologies, including Bluetooth Low Energy for device setup and Wi-Fi, Thread, and Ethernet for how to connect devices. Think of Matter as the common language that devices can communicate to each other. Thread is a key component in a Matter ecosystem because it provides an underlying mesh network to support constrained and battery-powered Matter devices. Another example of a smart home application is HomeKit. HomeKit was originally launched in 2014, and in 2020, Thread support was added. The Apple HomeKit framework enables apps to coordinate and control supported smart home devices, accessories from multiple vendors to present a user-focused, cohesive interface across applications on iOS, iPadOS, macOS, watchOS, and tvOS. Thread enhances HomeKit by providing a low-power, secure, and reliable mesh network for HomeKit-enabled devices and accessories. Lastly, you see proprietary. There is always the option for developers to create their own proprietary application layer to suit their own networking needs. So with that, I will now turn it over to Stuart, who will dive into the benefits of Thread.
Thank you, Sujata. We see here a list of many of the common technologies that are used for networking in homes and building. And at the bottom of the screen, you see a bunch of low-power wireless technologies. And I'm sure all of us in this webinar are very, very familiar with these. We all have Bluetooth on our phones. We probably have some of these other technologies in our homes. The other thing we have in our homes is IP communication. And typically for that, we use Ethernet or Wi-Fi. And the great benefit of IP is it lets you write your application once, and then the same software can run over Ethernet or Wi-Fi or Thread or any other IP network that comes along. And you see in the middle here, Thread sits at the overlap. It has very low power consumption, which is great for battery-powered devices. It's wireless, but it has the full flexibility of IP. So Thread really gives you the best of both worlds here. So let's drill down a little bit in more detail on the bottom half of that last slide. Let's talk about wireless networking in the home. Zigbee end devices don't speak IP themselves. Zigbee end devices always have to be associated with a hub. And typically, each vendor makes its own hub that supports its Zigbee devices. And many vendors don't even put Zigbee on the box. Zigbee is kind of a private internal design decision they make about how to manufacture their products. But the customer doesn't need to know that. They buy a starter kit, it has a couple of light bulbs in it, it's got a hub, and different vendors' devices usually don't work with a hub from another vendor. Or if they do work, they often have limited functionality, like they don't get firmware updates. These devices use Zigbee because of its low power consumption, but it comes with some compromises. Because each vendor makes their own hub, customers can very quickly get in the state where they have a whole stack of hubs. They have Zigbee hubs and Z-Wave hubs. You may not have heard of Bluetooth hubs, but they do exist. There are some Bluetooth products where the vendor sells a companion hub that acts as a gateway to the internet. And by the time the user's got half a dozen of these hubs stacked up, it pretty quickly becomes quite inconvenient. So moving on to the top half of my first slide, IP networking. We all use this all the time. It's become part of everyday life. Our favorite thing is Ethernet. If you can run a wire to your device, Ethernet is great. It's high throughput, it's low latency, it's very high reliability. You can even power the device over the Ethernet cable. Each device gets its own dedicated gigabit or more to the Ethernet switch. Ethernet is wonderful. Anywhere I can plug an Ethernet cable into a device, that's my first choice. If you can't run a wire, then Wi-Fi is great. Wi-Fi was created 25 years ago now, really as an Ethernet replacement. It was wireless Ethernet, and it was targeted at replacing the same use cases as Ethernet. It is great for high throughput. If you want to stream 4K video to your smart TV, Wi-Fi is great for that. When Wi-Fi was introduced 25 years ago, people didn't have smartphones. A typical customer maybe had one laptop and one desktop computer. They almost certainly didn't have a Wi-Fi connected printer. So Wi-Fi was targeted at giving the best throughput it could to one or two devices. And over the years, we've added more and more smartphones and tablets and thermostats and other devices to our Wi-Fi networks. What do all these technologies have in common? You don't need a different Ethernet switch to connect devices from different vendors. You don't need a stack of different Wi-Fi access points to support client devices from different vendors. And just the same with Thread, you don't need a stack of different Thread border routers to support different client devices. Thread is intentionally application agnostic network infrastructure. Because it uses IP, it forwards all IP packets equally without caring what's in them. The big wins of Thread compared to Wi-Fi and Ethernet is because Thread picked an appropriate data rate for smart home and building automation. That results in low hardware cost and, perhaps more importantly, very low power consumption. You can get Thread battery-powered devices that run for 2 years on a half-size AA battery. And if you tried to build that device using Wi-Fi, you'd probably be replacing that battery every 2 weeks, not every 2 years. One of the other big wins of Thread is the self-configuring mesh. Much of the time, people end up buying Wi-Fi range extenders or installing Wi-Fi mesh systems to ensure that they have good Wi-Fi coverage in their whole house. With Thread, you don't need to do that. One Thread border router is sufficient to cover your entire house, however big it is, because all the other powered Thread nodes that are part of the mesh forward packets on behalf of other nodes. So having a lot of Thread devices on your network doesn't overload the network. On the contrary, it makes the mesh stronger and more resilient. Now, you can have more than one border router, and if you do, that'll provide multiple paths onto your home infrastructure network. And that gives you better resiliency if one of those border routers gets disconnected or unplugged. But you don't need that. And if you do have more than one, the system automatically configures to take advantage of whichever one is best. We've talked a bit about IPv6. Don't let that scare you. Some people, if they're not familiar with IPv6, they worry about whether it'll be supported. IPv6, as far as Ethernet and Wi-Fi are concerned, are just packets. It doesn't matter what's inside them. The customer's home gateway doesn't have to support IPv6. The customer's ISP doesn't need to support IPv6. It's just like when people used to use AppleTalk or NetBIOS on their Ethernet networks. That's the point of the layered networking architecture model. The lower layers don't need to know or care what the higher layers are doing. So if that was a worry for you, then I can tell you, you don't need to worry about that. And you don't need to take my word for it. Thread is a mature technology. This is not something where you have to take a leap of faith and trust what you're told and hope it's going to work. You can go out today and buy Thread products for yourself and try them out in your home network. And I'm pretty confident you will have a good experience and be very happy with that. We've been using Wi-Fi since 1999, and it works really well. And that can make it tempting to think that Wi-Fi is perfect and it's ideal for everything. I am confident that everybody on this webinar probably has really excellent Wi-Fi equipment at home. But many of our customers don't. They may have a Wi-Fi access point provided by their ISP, built into the ISP hardware. It might be 5 years old. So many of our customers don't have the first-rate Wi-Fi that we have ourselves. And we're starting to run into some of the limitations of those old Wi-Fi access points. Vendors who ship Wi-Fi smart home products will tell you that some customers add their IoT products to a separate Wi-Fi guest network, and then they don't understand why they can't communicate with them. Some customers have access points that don't reliably forward packets between the 2.4 gigahertz and 5 gigahertz bands. Access points are supposed to do that, just like Ethernet switches are supposed to forward packets between the different ports. Some of them just don't work, or some of them work some of the time, but not other times, which makes it really hard to diagnose. Some mesh access point Wi-Fi systems don't always reliably forward packets between stations associated with different access points in the mesh. And we've even found some access points that don't reliably forward packets between two different clients on the same access point on the same band. Now, these problems are fairly rare, which is why you might not run into them yourselves in daily life, but they're not so rare that you can ignore them. They result in customer support calls, return products, and bad online reviews. In contrast, Thread was designed from the start for this explicit use case. Thread was designed to support smart homes and buildings. It was designed to support battery-powered devices with a limited energy budget. So that's why we do all this work on Thread, and we believe it is the best solution for automation devices for homes and buildings. And with that, I would like to invite Anne to tell you more about how Thread works.
Great. Thank you so much, Stuart. So next, I'm going to walk you through a couple example smart home topologies, or smart home topology and a commercial topology to show you a little bit of an example of how Thread works in real life. So first, I'm going to walk through Thread in a smart home with Matter devices. So I know there's a lot to see on this screen here, but bear with us and I'll take you through it. So in a smart home environment, integrating various devices and ensuring seamless communication is essential for a cohesive user experience. And this topology that you see on the screen illustrates how Matter and Thread devices can work together to create a reliable and efficient smart home network. As has been said, Thread provides a low power, secure, and scalable mesh network, and Matter ensures interoperability and reliable communication across different smart home devices. So together, they really form the backbone of a modern smart home. So there are some key components for you to take note of in this topology. And most importantly is the Thread border router. So you can see that in the middle of your screen in a solid orange dot with a Matter logo on top. That's your Thread border router. And the Thread border router acts as a bridge between the Thread network and other IP-based networks such as Ethernet and Wi-Fi. The Thread border router can be built into various devices such as access points, smart speakers, and more. And this border router ensures seamless communication between Thread devices and the internet or other smart home ecosystems. When using the Matter application layer, you're also going to need a Matter controller. So you can see some of those controller devices towards the upper right-hand side of your screen. And these devices manage and control Matter devices within the smart home. Importantly, Matter controllers can be integrated into smartphones, tablets, or even dedicated smart home hubs or speakers. And this provides a unified interface for controlling and automating those smart home devices. When it comes to the Thread mesh network, you can have multiple Matter devices from different brands and different types of devices sharing that same Thread mesh network. And this works to enhance the reliability and coverage by allowing devices to communicate directly or through intermediate nodes. You'll also see that there are some extender devices here. So these are represented in the open orange circle. So Thread mesh extender devices help to extend the network's range and improve connectivity. And these are typically mains-powered devices. Bridges for non-IP devices also enable some legacy systems to integrate with the Thread network, and I'll talk about that in just a second. We also have battery-operated devices. So these you see here in that kind of minty color on the bottom of the screen here. So these battery-operated devices, Thread supports ultra low power, battery operated devices, and making it an ideal choice for sensors and other IoT devices that require long battery life. And we'll talk about those in just a few more minutes. Now, you'll see in the upper left-hand side of your screen, we also have the optional Matter Bridge. So the Matter Bridge is an optional component that would allow control of other IoT network standards with Matter apps and devices. And so this ensures compatibility and interoperability with some of those legacy systems and non-IP devices that Stuart discussed earlier. So it's important to note that this smart home topology that you see here is just one example of how Thread can be used in a smart home. It demonstrates the power and the flexibility of integrating Matter and Thread devices. And by leveraging Thread's mesh network and Matter's interoperability, various smart home devices can work together seamlessly, providing a cohesive and scalable solution for modern smart homes. And next, I want to talk through how Thread would work in a smart building that maybe uses multiple automation standards here. So you'll see the same kind of structure here with the Thread border router, but then there are lots of other edge devices. So let's talk about this. In modern smart buildings, integrating various automation standards is really crucial for seamless operation and management. And this topology demonstrates how Thread devices using different standardized building automation protocols or even proprietary protocols can coexist and communicate effectively within a smart building environment. Traditionally, building automation platforms did not share IP infrastructure and were connected via gateways. And this often led to isolated systems that often required complex integration efforts. Now, with the advent of IP-based building automation platforms, devices can now connect via Ethernet or Wi-Fi, and now with Thread. And this allows for more straightforward integration and communication between different systems. Thread plays a pivotal role in this topology by providing a robust, low-power, and secure mesh network. So let's look at some of the key components in this system as well. So of course, like I mentioned, you've got that Thread border routers, and in this instance, you've got multiple border routers because that is also a possibility that Thread allows for. And again, this is going to ensure seamless communication between those Thread devices and cloud services or other building management systems that you can see at the kind of top center of your screen. Multiple devices then from different IP shared or IP-based building automation platforms then share the same Thread mesh network. And this enhances reliability and coverage by allowing devices to communicate directly or through intermediary nodes. So what you see on the screen here are some examples of some standardized building automation protocols that already work over Thread. So protocols like DALI Plus and KNX IoT, which Sujata discussed earlier, can operate over the Thread network, ensuring compatibility and interoperability. And using these application protocols over Thread brings all the benefits that Thread networking has to offer. First and foremost is that mesh capability, enabling the coverage of large areas or big buildings without complex wiring. So for example, here you could use KNX on Thread to use a mains powered Thread device as an extender for the data to reach its destination. And so a Thread mesh network, because it's fully self-healing, it can adapt to changes in the infrastructure. So you could imagine sensors being moved if you're taking down a wall in a particular office space and building a new wall, you can then move those sensor devices without having to worry about the wirings. It creates for really flexible smart building management. And that because the network is self-healing, the network will adapt to changes in the infrastructure, whether it's being removed, replaced, without any other additional wiring. Those Thread mesh extender devices will help to extend the network's range, of course, and improve connectivity. And then you can also use bridges for non-IP devices to enable those legacy systems to integrate with the Thread network. And then finally, those battery operated devices. This is so important in a smart building. Because Thread supports low power battery operated devices, it really makes it ideal for sensors and other IoT devices that require long battery life, especially if you've got devices that are behind a wall and they're hard to get to replace those batteries. Often Thread is an excellent choice. So if you've got window contacts, other sensors, they can work for up to 10 years on a single battery. The global 2.4 gigahertz band that's used by a Thread network means that manufacturers can make a single device SKU for worldwide usage, and it also greatly simplifies the component selection for system architects and planners. So again, Thread is a great choice for commercial buildings and smart buildings that utilize multiple automation standards. And you can see on this screen, we've got the 3 dots that also represent other nodes that we could expand to in the future. So now that we've gone through all of these 2 different networking topologies, I'd like to share a little bit more about Thread in action. So starting with member company Yale from Fortune Brands. Yale began investing in Thread technology in 2014, and they wanted to develop a smart lock that would set a new standard in home security. So they launched the Nest and Yale lock in 2017, and that partnership really gained momentum for them, and it addressed a lot of connectivity issues that they were seeing, and it also improved battery life. By integrating Thread technology, this resulted in more reliable smart locks with fewer disruptions and longer battery life, leading to increased customer satisfaction, which we love to hear. Yale then became the first lock to join a production-ready Thread network with the Yale Assure Lock SL with Matter, setting a new industry benchmark. And Thread technology has solidified Yale's position as a leader in the smart home market, unlocking new business models and paving the way for more innovative products. NAMI is another Thread member, and they are revolutionizing safety and wellness using their products. They really redefined safety and healthcare solutions through its fusion sensing platform, leveraging AI and RF sensing technologies. Integrating Thread technology has significantly enhanced NAMI's sensing infrastructure, providing unparalleled privacy and performance. Thread's self-healing mesh architecture enables NAMI's platform to deliver scalable and reliable connectivity, which is crucial for their safety and wellness applications. And NAMI's panelist security and wellness solutions open new opportunities in previously unsupported or untapped markets, offering easy DIY setup and robust analytics. The adoption of Thread has unlocked innovative revenue streams in both safety and healthcare sectors, positioning NAMI as a leader in delivering reliable, accessible solutions. And finally, Aqara, who's a well-known product manufacturer in the smart home. Aqara leveraged Thread technology to eliminate the need for a proprietary hub, simplifying the end user experience and making their devices more appealing to a broader audience. Thread technology unlocked Aqara's competitive advantage, expanding their market reach and reinforcing their position as an industry leader. And the adoption of Thread technology boosted Aqara's sales, and as consumers increasingly sought out smart products with enhanced interoperability. And it also opened up then new business opportunities for them, with retail channels favoring devices that support major smart home platforms out of the box. Thread adoption really sped up Aqara's time to market and reduced development efforts, allowing them to focus on innovative, user-centric designs. And I think that's been reflected in a lot of the device reviews that you see for this brand. And to wrap up Thread in action, I want to share a little bit more about some certifications that we've seen recently. Thread Group saw an increase of over 200% in certifications of Thread certified products in 2024, which is a huge increase. And we expect that momentum to continue. And about 80% of those certified products that you see on the Thread Group's website are available today for purchase. This reflects a trend from companies that are looking to accelerate the adoption of the development of Thread with products that support Matter. And Thread Group is also seeing traction via our liaisons with Dolly and KNX commercial standards, as they've brought Thread in to support their member companies' growth as well. So you'll see a smattering of the latest Thread certified devices on the left-hand side here. And you can see on the right some of the typical device types that are really seeing the most benefits with Thread. So there's door locks, which includes kind of touchscreen interfaces, deadbolts, etc. Window coverings, so shades, roller blinds, and curtain motors, these kinds of devices that are really difficult to replace those batteries on, as well as sensors and other smart home device types. So now I'm going to pass it over to Daniel to talk about Thread in action in 2025.
Thanks, Anne. So before we talk about what to expect going forward, it's important to note that Thread is already driving success for popular smart home brands today. As Anne just spoke about, Thread is already a differentiator for smart home products, particularly in key categories like lighting and door locks. Whether that's from smart home savvy users that are preferring Thread products specifically, or from mass market users purchasing them because of their responsiveness, range, and battery life, product makers are already seeing benefits from those investments in Thread. Enabling those investments is also the fact that the required infrastructure, that is Thread border routers, which you've heard a lot about, are already included in many popular devices like smart speakers, TVs, and set-top boxes, Wi-Fi routers, and even appliances. In 2025, we expect Thread infrastructure to become even more ubiquitous, and that's in part due to increasing distribution through those products I just mentioned, but also adding to that will be a newly enabled class of Matter home router and access point devices, like Wi-Fi routers with Thread built in as a requirement. So we expect to start seeing those from popular AP makers and ISPs. We're also now in the era of Thread in mobile devices and expecting that to become more accessible to developers and available to users. That's especially useful for those just starting a smart home and don't yet have a hub or a border router, or for developers building Thread-based mobile tools. And finally, we expect new and existing Thread devices and networks that are already out there to be even easier for users to build and grow. For instance, support for Thread credentials in iOS and Android key stores already available makes it easier than ever for users to add new devices to their Thread networks or expand their networks with border routers. Thread 1.4 introduces further standards-based enhancements to credential sharing, making it easier to build devices and infrastructure that can securely share credentials, improving onboarding experiences for users. And if users do run into challenges or just want to strengthen their networks, standards-based network diagnostics will help product makers, installers, and users address issues and improve network performance. And finally, improvements like commissioning at scale, which enables offline pre-commissioning of Thread devices, and Thread over infrastructure, which enables unifying separate Thread networks over large-scale networks in an office or commercial installation, aligns Thread with the needs of those commercial operations, helping Thread expand further into those markets as well. And with that, I'll be handing it back to Sujata for a wrap-up.
Thank you, Daniel. Let's move into a quick wrap-up, and then we will jump into Q&A. So now that you've heard from all of the speakers here about what Thread is, the benefits that Thread brings, seeing some examples of Thread in action, and then what to expect in 2025, there's many different ways you can get engaged with Thread. You can work with your silicon vendor to start doing prototyping if you're not already doing that, developing your product concepts to leveraging the benefits that Thread provides, joining Thread Group, and then certifying a product and deploying it to the market. We also encourage you, if you're not already a Thread Group member, to join Thread Group and get engaged with our activities within the marketing and technical committees. There's always significant amount of work, and the different perspectives that member companies bring helps us advance Thread to address the challenges and use cases the market is experiencing. So with that, I will turn it back over to Anne so that we can get started on the Q&A.
Great. Thank you so much, Sujata. And as a reminder, if you have any remaining questions, we've got quite a lot here that we're looking through right now. But if you've got more questions, please use that Q&A feature at the bottom of your interface. Okay, so let's get started. So first question that I see here is, will we have battery-to-battery communications on Thread? And Sujata, I'm going to pass that question to you. Sujata, you're on mute.
Thank you for that reminder. So as you saw on the network diagrams that Anne shared, there are different types of roles that devices in a Thread network play. The battery-powered devices are typically the sleepy end nodes or sleepy end devices. And in the network, these devices stay in sleep mode to conserve battery power and wake up and check for messages from their parent. So there is a single parent assigned to each sleepy end device. So technically, the devices as one sleepy end node cannot communicate directly to another sleepy end node, but it can do so by leveraging the mesh and sending the message to the parent in the network that is responsible for that specific sleepy end device. And this is designed on purpose because of optimizing for battery-powered applications. But a really great question.
Great. Thanks so much for that, Sujata. Okay, next, a question here about Thread border routers, and I'm going to pose this one to Daniel. Will collaboration between different border routers in a home be improved? In other words, with credential sharing?
So the short answer is yes. We are already seeing Thread border routers being interoperable in homes. I for instance, have a couple of actually more than a couple of border routers in my house that are now part of a larger network. I think initially, particularly with Matter-based ecosystems, when they rolled out, the sort of default behavior was to set up a new Thread network. But as I mentioned before in the presentation, now that we're seeing support in mobile OSs for storing Thread credentials, and with the updates coming through both Thread 1.4 and Matter ATRAP, there are a number of ways to easily and securely share Thread credentials. And so that means as you add a new border router to your home, that border router will join any existing ones that are there. It will know that there are existing ones there and join them. And similar with devices. And so we do expect to see not just technical interoperability, which is already there, but practical interoperability through user experience enhancements that some of which are already available in users' hands today.
Great. Thank you for that answer, Daniel. Okay, I am looking through the rest of our questions here. Okay. There are a couple questions here that are quite technical, and some of the panelists were discussing in the background here that some of these will take a little bit more time for us to answer. So we're going to take a look at some of these offline and follow up individually. And so next, I would like to pop over to a little bit of a different topic here. So here's a question. Do consumers need to buy a new router or a hub to make Thread work? And Sujata, I'm going to pose that question to you. It's a question that comes up quite a lot, you know, if consumers need to buy any new infrastructure to make Thread work today.
Yes, thank you. So Thread does need to have an infrastructure in place to support the Thread network. One of the fundamental components of a Thread network is the Thread border router, because that is what connects the local Thread network to the internet. And so there has been a need to communicate around when you have a Thread border router in your home versus if you're missing that. And Thread has different badges for end devices to indicate that. So there's a thread certified device badge that has the border router logo on it. And then there's one that says needs a border router. And it is key to note that border routers are not a device type on its own. It really is more about a functionality that can be embedded in many existing devices that are always powered and managing networks, like a Wi-Fi access point could have Thread border router functionality in it, as well as smart speakers. We've even seen some announcements from member companies like Akara, where they're implementing a Thread border router functionality into a smart switch. So there are multiple ways for this infrastructure to be built into the smart home.
Awesome. Thanks for that clarification. All right, great. We've got more questions coming in. This next question here is about privacy. So Daniel, I'm going to pose this one to you. How does Thread ensure device privacy?
So it's an interesting question. So the way I would say it is that Thread helps to give users more control and more choices over their security and privacy. Thread is a local network, so a Thread device connects directly to other devices in the home and can speak to devices in the home across that network. So depending on what application layer you choose, for instance, if you've got a Matter over Thread device, all of the command and control functions that are required of that device can happen within the home. In fact, with Matter exclusively happen within the home. And so a user could choose a device from a company that does not have or does not require any sort of cloud connectivity or anything like that. If they're on one end of the continuum and just like don't want that device to communicate externally, you could probably even set up your router to deny devices external access if that's really a concern, and they'll still be able to function. Now, one caveat there is, as Stuart points out, Thread is an IP-based technology. So devices on the network in the home, they can talk to other devices in the home. They can also talk to the cloud, or they can talk to an app. And for many devices, that is a big benefit. They have features and functionality that is supported by that. For device makers, that helps them to deliver enhanced functionality. And users, as always, have to use their judgment and get devices from brands that they trust and whose data privacy policies they trust. But again, here it gives users much more choice, because not everything has to go through the cloud just to work. So users can really choose their devices based on the level of privacy and data sharing and internal versus external connectivity that they're comfortable with.
Great. Thanks for that, Daniel. All right, I see a question here. Someone is curious about the new features that are being worked on. And while we would love to share all of that, it is private information for Thread group members right now. So I'm going to pose a similar question to Sujata about some of the features that are in 1.4. So Daniel touched on these, but maybe you could extrapolate a little bit more on what are those new features in 1.4.
Sure, Anne, and it's a great question. So Thread 1.4 was announced and released last year in the fall, and so we hope to start seeing end devices in the market this year. Some of the key features that were included in Thread 1.4, first is the one that Daniel talked about around creating a single thread network in the home when bringing in new devices, so border routers can share credentials. Another one that you may not be as familiar with is around cloud connectivity, to have direct connectivity from an end device to the cloud through the border router. And this specific feature is used to enhance the user experience. So a product device manufacturer can choose to grab some sort of relevant data from the cloud that provides a user experience. So for example, your thermostat can, instead of having, if there's no sensor outside giving the temperature, it can grab the latest temperature from the cloud. The other key feature that Thread added in Thread 1.4 was around creating a more robust and larger network by leveraging existing links in the smart home. So using Wi-Fi and Ethernet connections to really extend the Thread network. And another great feature that's been added is really more for developers to be able to gather more information that can help in debug and network troubleshooting issues. So with Thread 1.4, different types of information about the device, around the role it is in the network, and other parameters are provided along with the packet information about that device. And that can be used by developers to create tools or applications to do the network troubleshooting. The other feature that we added is to really address more of the commercial building space where you have to commission devices at scale. So let's say you're installing hundreds of light bulbs. The installer with the previous version of Thread would need to use scan the QR code. So have to get up on a ladder and use the phone to scan the QR code or punch in a manual number. With Thread commissioning at scale, it allows the installer to use their phone still, but not have to be close and taking doing a QR code scan. And so it uses TLS, or transport layer security, to do secure onboarding to devices that are already installed in the home. Those are really some of the main features that we have provided in Thread 1.4. And I know the question really was about what is coming next, but like Anne said, there's always activity going on within the Thread group membership. If you are at a contributor level or above, and the technical and marketing committees work together to define use cases and then look at the solutions to address those use cases.
Great. Thank you so much for that insight, Sujata. So I see we've got a lot more questions here. We do need to wrap up in just a few minutes. Daniel, I'm going to pose a question to you about mesh network, how the mesh network is healing. But I do want to address one question here about matter over thread communication between thread devices doesn't work anymore if the border router is down. So can it be improved? So actually, if you have a smartphone today with Thread, you can really use those Matter devices without a border router. So this is not something that is very well known right now, but it does exist. So go ahead and see if you can give that a go. Daniel, the last question I'm going to pose to you the question here is, I wonder what factors affect how fast a Thread network heals itself when some of the intermediary devices are down. Can you speak more to that?
Sure, and maybe to just speak to that last question a bit as well. While it's true, if your Thread border router is down for some reason, those devices might not be able to access, the rest of your network. But we really envision a universe in which a user has more than one Thread border router in their home. In fact, that's very likely if you've got, a couple of smart speakers from one platform, or maybe one from one and one from the other. If Thread is becoming more ubiquitous in routers, it's very likely that users will have multiple hubs within their home. For instance, putting my SmartThings hat on here, we're pretty much putting a hub into everything that moves. So you might have a Thread border router in your TV and in your fridge, as well as your home router. And this is intentional. This isn't redundancy for no reason. It makes the mesh more stable. It makes it gives it larger range, and it means that if one of those border routers for some reason goes down, the rest of your network stays out. So we really do envision that consumers won't have these single points of failure. But obviously, it's a good question. As Anne mentioned, there are other solutions for users, especially in special circumstances. Let's say the power goes out and things like that. Technologies like Thread and mobile will help improve that. As for the speed of network recovery, again, I think this is one of those technical answers that probably requires a deeper dive, is that there's a number of factors that go into that here, including whether devices are battery operated, etc. Certainly in my experience, that has been quite quick, whether it's literally actually, as I just mentioned, like unplugging a border router and having the devices continue to be responsive, or removing devices in between and having them continue to communicate with each other. For most users, unless you really have a device that's very, very much relying on like a single other device as a relay into the rest of your network, you're probably not going to notice the network reconfiguring itself.
Great. Thank you so much for that, Daniel. And thank you to all of our panelists today. And thank you for all of you who attended. For more information, please do visit our website, or you can contact the Thread group at our help email address. We will be emailing these slides and a recording out after we wrap, and you'll also be able to find it on the website. And if you're not already, please do connect with us on social media. And thank you again so much for attending. It was a pleasure to discuss with you today. Thanks, everybody, and have a good day.